Hello there, and a very warm welcome to the Bedtime Lab, where we share soothing stories and intriguing facts to guide you gently into a peaceful slumber. Tonight, we're exploring the fascinating world of space elevators and skyhooks. These are not just ideas from the realm of science fiction, but rather tantalizing possibilities that could redefine how we venture into space. Let's embark on this dreamy journey together. Speaking of which, have you ever wondered how we might one day reach the stars without the need for rockets? Imagine an elevator stretching from the surface of our planet all the way into space. This is the concept of a space elevator. It's something that sounds straight from a dream, yet it's a topic of serious scientific discussion. The idea is that by using a tether anchored to the Earth and extending into space, we could transport materials and people to orbit with much greater efficiency. Here's a fascinating thought. A space elevator could significantly reduce the cost of sending payloads into space. Traditional rocket launches are incredibly expensive, but with a space elevator, the cost per kilogram could be reduced to a small fraction of current prices. This would open up space travel to more nations and companies, potentially leading to a boom in extraterrestrial exploration and innovation. Did you know that the concept of a space elevator was first proposed in the late 19th century? Russian scientist Konstantin Tsiolkovsky, inspired by the Eiffel Tower, imagined a celestial castle connected to Earth by a tower. Though Tsiolkovsky's vision was at the time beyond the capabilities of existing technology, it laid the groundwork for future generations to dream even bigger. Now, let's shift our gaze to another captivating idea, the skyhook. Unlike a space elevator, which is anchored to the Earth, a skyhook would orbit our planet, acting as a rotating tether that captures spacecraft and accelerates them to higher orbits or even towards other planets. With a skyhook, we could potentially reach destinations in our solar system with less energy, making interplanetary travel more feasible. Here's something interesting to ponder. While both space elevators and skyhooks rely heavily on advances in material science, the theoretical materials needed for a skyhook are slightly more attainable with today's technology. Strong fibers, such as carbon nanotubes or graphene, could potentially be used to construct these tethers. Though we are still some way from creating them at the necessary scale, can you imagine a future where space elevators connect Earth to space colonies on the Moon or Mars? This could transform our approach to colonization and resource extraction on other celestial bodies. A space elevator on Mars, for instance, could facilitate the transport of valuable materials back to Earth, while also supporting the needs of a growing off-world community. It's amazing to think that Arthur C. Clarke, the celebrated science fiction writer, once said that space elevators would be built about 50 years after everyone stops laughing. This quote highlights the skepticism that often accompanies groundbreaking ideas, yet history shows us that today's impossibilities can become tomorrow's realities. Here's a little-known tidbit. While there is no current space elevator, several designs have been proposed, including one that uses a counterweight in space to maintain tension in the tether. This counterweight could be anything from an asteroid to a large space station, creatively utilizing existing mass in our solar system. Speaking of asteroids, did you know that they could play a crucial role in the construction of space elevators? By capturing an asteroid and using it as a counterweight, we could potentially stabilize the tether against the forces of Earth's rotation. This would not only be a feat of engineering, but also an innovative use of natural resources in space. Another intriguing fact is that space elevators could reduce the environmental impact of space travel. Rockets, while impressive, release significant amounts of greenhouse gases and other pollutants. In contrast, a space elevator would have a much smaller carbon footprint, aligning with global efforts to reduce emissions and protect our planet. And here's something to marvel at: the speed at which a space elevator could transport cargo and passengers. Though slower than a rocket in terms of initial acceleration, it would offer a continuous and gentle ascent, reaching geostationary orbit in about a week. This gradual journey would provide stunning views of our planet, offering a unique travel experience. Have you ever considered how space elevators could revolutionize satellite deployment? With a tether extending into space, we could deploy satellites directly into geostationary orbit without the need for complex launch vehicles. This would not only simplify the process, but also increase the lifespan of satellites by placing them directly into their final orbits. And as we continue this contemplative exploration, I invite you to share where you're tuning in from. It's always wonderful to connect across the distances, much like the space elevators and skyhooks we're imagining tonight. Your thoughts and dreams add to the tapestry of this gentle journey we're on together. So, as you drift further into the world of dreams, ponder these celestial possibilities and perhaps imagine a future where humans move freely between Earth and the stars. Our journey has just begun, and there are so many more facts and wonders to explore as we delve deeper into this enchanting topic. Let your mind wander among the stars as we continue to unravel the mysteries of space elevators and skyhooks. One captivating aspect of space elevators is their potential to serve as a backbone for a network of space-based solar power stations. Imagine satellites equipped with solar panels, gathering energy from the sun and transmitting it down to Earth, providing a clean and practically limitless energy source. This system could be made more efficient with a space elevator, as it would facilitate the construction and maintenance of these solar arrays. Did you know that the tether of a space elevator could act as a conductor, transmitting energy collected in space back to Earth in a sustainable way? Here's a thought-provoking possibility. Space elevators could enable the construction of large habitats in orbit, creating new living spaces for humanity. These orbital communities could serve as research stations, tourist destinations, or even manufacturing hubs where the microgravity environment is advantageous. Can you envision a future where space elevators not only carry us to these new homes, but also support them with resources from Earth and beyond? Speaking of resources, space elevators could play a critical role in asteroid mining. By providing a direct and economical route to and from space, they would facilitate the extraction of valuable materials like platinum, gold, and rare earth elements from asteroids. This could revolutionize industries on Earth, making rare materials more accessible and reducing the need for terrestrial mining. Now, let's consider the environmental benefits once more. The introduction of space elevators could dramatically reduce the amount of debris in Earth's orbit. Traditional rocket launches often leave behind stages and other components, contributing to the growing problem of space debris. However, a space elevator would have fewer disposable parts, leading to a cleaner and safer space environment. Isn't it intriguing that the concept of a skyhook could be used not only for transportation but also for scientific exploration? By attaching instruments or probes to a rotating skyhook, we could gather data from different altitudes or even deploy them on trajectories to other planets. This mobility could yield new insights into our solar system and beyond, enhancing our understanding of planetary atmospheres and surface conditions. Consider this: the synergy between space elevators and current spaceports could drastically change how we think about launching into space. Instead of multiple launch sites around the world, a centralized space elevator could handle a significant portion of space traffic, making launches more predictable and increasing efficiency in scheduling. Here's a fascinating fact about the Skyhook concept. It could serve as a midway station for spacecraft traveling to the Moon or Mars. By docking with a skyhook in orbit, a spacecraft could gain additional velocity, reducing the fuel required for the journey. This technique, known as a momentum exchange, uses the skyhook's rotation to slingshot spacecraft on their way, conserving energy and resources. The potential for space elevators to facilitate international collaboration is another aspect worth pondering. Constructing and operating these massive structures would likely require the combined expertise and resources of multiple countries. Such collaboration could foster new relationships and shared goals, ultimately advancing humanity's spacefaring capabilities. Ever thought about the impact on telecommunications? Space elevators could significantly enhance communication networks by providing stable platforms for satellites and antennas at various altitudes. This could improve internet connectivity, broadcast services, and global communications, bringing us all a little closer together. And here's another surprising aspect. The construction of space elevators and skyhooks could spur advancements in robotics and automation. These technologies would be crucial for building, maintaining, and operating such structures, potentially leading to breakthroughs that could benefit industries on Earth, like manufacturing and logistics. Imagine the educational opportunities unlocked by space elevators. Schools and universities could use them as platforms for research and learning, inspiring students and fostering the next generation of scientists and engineers. Field trips to space could become a reality, offering first-hand experiences that ignite curiosity and innovation. Think about the psychological impact of seeing the Earth from space. Space elevators could make this view accessible to more people, potentially shifting our perspective on global issues. Experiencing the planet from above might foster a greater sense of unity and responsibility towards our shared home, promoting sustainable practices and environmental stewardship. Here's a whimsical idea. Space elevators might enable space tourism on an unprecedented scale. Picture yourself enjoying a leisurely ascent to orbit, with panoramic views of our blue planet as your backdrop. This could make space travel a mainstream activity, opening the cosmos to adventurers and dreamers alike. Finally, consider the resilience that space elevators could bring to our space infrastructure. In the event of natural disasters or geopolitical tensions, having a reliable and swift means of reaching space could be critical for disaster response or ensuring access to vital satellites and technologies. As we continue this journey through the stars, let these possibilities linger in your thoughts. The future of space elevators and skyhooks holds a universe of opportunities waiting to be discovered and explored. So, as you relax and drift off, let your imagination soar among these visionary ideas, dreaming of a world where such wonders are within our reach. Imagine the transformative effect space elevators could have on renewable energy. By providing access to the constant sunlight available in orbit, these structures could support large-scale solar power stations that beam energy back to Earth. This is not just about cleaner energy. It's about a profound shift in our energy systems, potentially reducing reliance on fossil fuels and mitigating climate change. Isn't it fascinating to think that space elevators might help us harness the power of the sun more effectively than ever before? Speaking of sustainability, consider the materials required for constructing a space elevator. Current concepts often mention carbon nanotubes or other ultra-strong materials that are still in development. These materials need to have an incredible tensile strength to support the elevator's length and weight. The push to develop such materials could lead to innovations in other fields, such as construction and materials science, spawning new technologies and applications on Earth. Here's a curious thought. The concept of building a space elevator is not as new as you might think. The idea dates back to the late 19th century and was initially inspired by the Eiffel Tower. Can you imagine the vision of creating a structure that reaches from the surface of the Earth all the way into space, conceived during a time when human flight was still a dream? Imagine the effect a space elevator could have on global travel. With access to space becoming more routine, we could see a new era of international cooperation and cultural exchange. A trip into orbit might one day be as commonplace as a flight across the ocean, with passengers from all corners of the globe sharing their stories and experiences. Let me share something interesting about the logistics of space elevators. They could dramatically reduce the cost of sending cargo to space. Currently, launching payloads is incredibly expensive due to the need for powerful rockets. By contrast, a space elevator could transport goods at a fraction of the cost, making space more accessible for scientific experiments, commercial endeavors, and humanitarian efforts. Here's something intriguing. Space elevators may also transform satellite deployment. With the ability to position satellites precisely at different heights, we could enhance global communication networks, improve weather forecasting, and even monitor environmental changes more effectively. This flexibility might lead to a more connected and informed world. Consider the potential for space elevators to serve as lifelines for space settlements. These structures could ensure a steady stream of supplies and personnel to and from orbital habitats or lunar bases, supporting their growth and sustainability. You might even think of them as bridges between worlds, connecting humanity's expanding presence in space with its roots on Earth. Speaking of connections, the concept of a space elevator is not limited to Earth. Similar systems could be established on other celestial bodies, such as the Moon or Mars. The lower gravity on these bodies makes the construction of space elevators more feasible, potentially aiding in the development of colonies and boosting exploration efforts. Can you imagine a future where space elevators are as common on other planets as they are on Earth? Let's reflect on the potential security benefits. Space elevators could serve as platforms for monitoring Earth's environment, giving us better tools to detect and respond to natural disasters or track climate changes. This enhanced capability could play a vital role in safeguarding our planet and improving our ability to cope with challenges. Here's another surprising possibility. Space elevators could revolutionize manufacturing. The microgravity environment of space provides unique conditions for producing certain materials and products that are difficult or impossible to create on Earth. With a space elevator, these manufacturing sites could be established in orbit, leading to new industries and economic opportunities. And here's something that might surprise you. Even art and culture could be transformed by space elevators. With easier access to space, artists and performers might explore new forms of expression, using the vastness and beauty of space as their canvas or stage. Imagine concerts or art installations in orbit, offering a blend of creativity and science that captivates and inspires. The notion of using space elevators for farming might seem far-fetched, but it's worth considering. In the zero-gravity environment of space, certain crops could potentially grow more efficiently, with resources like sunlight and water being managed in innovative ways. This could lead to advances in food production techniques that benefit both space settlers and those of us back on Earth. Finally, let's ponder how space elevators could influence geopolitics. The strategic advantages of having access to space could shift power balances and drive nations to cooperate more closely. As countries come together to share technology and resources, A space elevator might become a symbol of peace and collaboration, uniting humanity in the quest to explore the stars. As these thoughts gently swirl around you, imagine the endless possibilities that space elevators and skyhooks present, not just for exploration, but for life here on Earth. Let your mind drift through this tapestry of potential, dreaming of a future where these grand structures are as integral to our world as the ships that once crossed our seas. Imagine for a moment the possibilities of a skyhook. Unlike space elevators, which stretch from the Earth's surface to space, skyhooks are more like dynamic tethers that hang in low orbit. As they spin, they offer a moving platform that can pick up payloads from Earth and release them into higher orbits. Isn't it intriguing to think that a skyhook could act like a cosmic catapult, launching spacecraft with minimal fuel? This could be a game-changer for missions that require frequent trips between Earth and its orbital neighborhood. Speaking of fuel efficiency, skyhooks could significantly reduce the amount of propellant needed for space travel. By using the momentum of the skyhook itself, spacecraft might only require a fraction of the energy they currently use to reach orbit. This efficiency could lower costs and open the door to more frequent space missions, accelerating our exploration of the cosmos. Can you imagine a future where the sky is no longer a barrier, but a gateway? Here's another fascinating thought. The technology used for space elevators and skyhooks could help us better understand and harness the forces of gravity and momentum. By mastering these forces, engineers might develop new propulsion systems or energy storage solutions that benefit technologies on Earth. Think about how such advancements could ripple through industries, leading to more sustainable energy practices and innovations. Consider the remarkable engineering challenge of building a space elevator. The counterweight needed to balance the elevator's immense structure could be an asteroid or even a purpose-built station in orbit. This concept not only highlights human ingenuity, but also presents opportunities for asteroid mining, tapping into the rich resources that these celestial bodies hold. Mining asteroids could supply rare materials that are scarce on Earth, driving new economic ventures in the space industry. Did you know that space elevators might also contribute to a cleaner space environment? By providing a reusable means of transport, they could reduce the number of spent rocket stages and debris left in orbit. This cleaner space environment would be safer for satellites and spacecraft, helping to preserve the orbital space around Earth for future generations. Imagine a sky where our technological footprint is as minimal as possible, allowing the stars to shine through clearly. Speaking of clear skies, space elevators could also transform the way we conduct astronomy. With platforms situated high above Earth, free from atmospheric interference, telescopes could capture clearer, more detailed images of the universe. This might lead to breakthroughs in our understanding of the cosmos, bringing us closer to unraveling its mysteries. Can you picture the discoveries waiting just beyond our grasp, ready to be unveiled by these lofty observatories? Here's a thought that might surprise you. The development of space elevators and skyhooks could spur new disciplines within science and engineering. Fields like megastructure engineering and space dynamics would grow, attracting bright minds eager to tackle the challenges of building and maintaining these colossal constructs. The cross-pollination of ideas among scientists, engineers, and architects could lead to unexpected innovations and inspire the next generation of explorers. Imagine the social implications of these structures. Space elevators and skyhooks could democratize access to space, opening up opportunities for people from all walks of life to experience the wonder of space firsthand. This democratization might not only inspire individuals, but also fuel cross-cultural collaborations as people from different backgrounds unite in the pursuit of knowledge and exploration. Picture a world where space travel is as accessible as air travel, broadening horizons and fostering global understanding. Reflect on this. The concept of space elevators could reshape urban planning and architecture on Earth. The technologies and materials developed for these projects could lead to smarter, more resilient cities that integrate seamlessly with the environment. Innovations in sustainability and efficiency might become standard, transforming the way we build and live. Imagine cities that thrive in harmony with nature, inspired by the engineering marvels stretching toward the heavens. Did you ever wonder about the impact on education? The creation and operation of space elevators and skyhooks could inspire new educational programs focused on space sciences and engineering. Schools and universities might develop specialized courses that prepare students for careers in these burgeoning fields. This focus on space education could nurture a new generation of thinkers and innovators, ready to drive humanity's exploration of the cosmos forward. If we turn our gaze further afield, consider how these structures might influence our colonization of other planets. On Mars, a space elevator could facilitate the movement of people and supplies, supporting the growth of settlements and encouraging scientific research. By lowering the barriers to accessing the Martian surface, these elevators could make colonization more feasible, turning science fiction into reality. Imagine standing on the red planet, knowing that a tether connects you to the wider universe. As your thoughts meander through these possibilities, reflect on the ways space elevators and skyhooks could alter our perspective on life and the universe. These structures might not only bring us closer to the stars, but also closer to each other, fostering a sense of shared purpose and destiny. The bridges we build to the sky could ultimately become bridges between worlds, linking our dreams with the infinite possibilities above. Allow yourself to drift on this gentle tide of imagination, envisioning a future where the sky is no longer the limit, but a beginning. Let me share a captivating idea with you. The base of a space elevator on Earth would need to be located near the equator. This is because the equator rotates at the highest velocity, providing the necessary centrifugal force to keep the tether taut. Can you picture such a facility nestled somewhere like Ecuador or the Maldives, acting as a gateway to the cosmos? Speaking of gateways, the materials required to construct a space elevator are as extraordinary as the concept itself. Scientists are exploring the use of carbon nanotubes or graphene, which possess remarkable tensile strength, to withstand the immense forces the elevator would endure. These materials are not just strong, but incredibly light, making them ideal for such ambitious structures. Here's a thought-provoking detail. As the elevator car climbs the tether, it would transition through different layers of the atmosphere, each with its own unique characteristics. Weather patterns, temperature changes, and atmospheric pressure shifts would all be part of this incredible journey skyward. Imagine watching the Earth transform below you, from the vibrant greens and blues to the vast stretch of space. Did you know that a space elevator could also function as a laboratory? By positioning experiments along the tether at various altitudes, scientists could study atmospheric phenomena or conduct zero-gravity research without having to launch separate missions. This would open up new avenues for scientific discovery, enhancing our understanding of both our planet and the space beyond. And here's something fascinating. Constructing space elevators and skyhooks could lead to advancements in robotics and automation. Given the complexity and scale of these projects, Autonomous machines might be used for tasks such as tether maintenance or module assembly. These robotic innovations could then find applications in other industries, revolutionizing the way we approach large-scale construction and manufacturing. Consider this: the concept of a space elevator isn't entirely new. It was first popularized by Russian scientist Konstantin Tsiolkovsky in the late 19th century, inspired by the Eiffel Tower. Tsiolkovsky imagined a structure reaching into space, and while his vision was ahead of its time, it laid the groundwork for the theories we're exploring today. Isn't it intriguing how ideas can evolve over time, bridging the past and future? Speaking of the future, space elevators could play a crucial role in space tourism. Imagine a leisurely ride to the stars, offering unparalleled views of Earth and the celestial wonders beyond. This experience could transform travel, making the dream of seeing our planet from space more accessible to people from all walks of life. Here's another interesting point. The energy source for powering a space elevator might come from renewable technologies, such as solar or wind power. By harnessing the energy of the sun or capturing the wind's force, these structures could operate sustainably, leading the way towards greener technologies both on Earth and in space. In this context, tethered skyhooks might also serve as platforms for space-based solar power stations, capturing sunlight without atmospheric interference and transmitting the energy back to Earth. This clean, abundant energy source could address some of our planet's most pressing energy challenges, illuminating a path toward a more sustainable future. Let me tell you about the potential economic impact. The construction and operation of space elevators and skyhooks could create thousands of jobs in engineering, construction, and technology sectors. This influx of opportunities might stimulate economies around the world, fostering innovation and collaboration on a global scale. Picture communities thriving as they contribute to humanity's ascent into space. And here's something that might surprise you. Space elevators could influence global communication networks. By positioning satellites along the tether, we could enhance telecommunications infrastructure, improving connectivity and data transmission across the globe. This could bring the world closer together, bridging the digital divide and enabling more equitable access to information. Can you imagine the environmental benefits? By reducing the need for conventional rocket launches, space elevators could significantly cut greenhouse gas emissions associated with space travel. This reduction could have a profound impact on efforts to combat climate change, demonstrating a commitment to preserving our planet even as we reach for the stars. As you ponder these possibilities, consider how space elevators might foster international cooperation. Building and maintaining such structures would require a collaborative effort, bringing together nations and organizations in the pursuit of a shared vision. This spirit of cooperation could extend beyond the technical realm, encouraging peace and unity as we explore the universe together. Reflecting on all these surprising aspects, it's clear that space elevators and skyhooks offer more than just a means of reaching space. They represent a shift in how we perceive and interact with our universe, challenging us to think beyond current limitations and embrace the potential of human ingenuity. As you drift into a gentle slumber, let your imagination wander through these infinite possibilities and dream of a world where the sky is a bridge, connecting us to the cosmos and to each other. Let me share something intriguing about the potential impacts of space elevators on our understanding of gravity. By observing the gravitational pull along the tether, scientists could gain new insights into how gravity behaves at different altitudes and distances from the Earth's surface. This could lead to breakthroughs in our understanding of fundamental physics, shedding light on phenomena that have puzzled scientists for years. Speaking of phenomena, the concept of a space elevator has inspired imaginative solutions to some of the most daunting challenges in space exploration. For instance, the notion of a counterweight or anchor in geostationary orbit could help stabilize the structure, ensuring that it remains balanced despite the forces acting upon it. Can you picture a celestial anchor floating silently in the void, providing a steady hand to guide humanity's ascent? And here's another fascinating aspect. The development of space elevators could revolutionize how we launch satellites and deploy spacecraft. With a direct route to orbit, payloads could be delivered more efficiently and cost-effectively, reducing the need for traditional launch vehicles. This could democratize access to space, enabling more countries and organizations to participate in space exploration and research. Imagine a world where launching a satellite is as routine as sending a shipment across the ocean. The implications for global science and technology could be profound, potentially accelerating the pace of discovery and innovation. Now, did you know that space elevators could also serve as platforms for astronomical research? By positioning telescopes along the tether, astronomers could observe the cosmos from above much of the Earth's atmosphere, providing clearer, more detailed views of distant galaxies and celestial events. This could lead to unprecedented discoveries, deepening our understanding of the universe and our place within it. With each step along the tether, the stars would come into sharper focus, beckoning us to explore their mysteries. The potential for space elevators to enhance our planetary defenses is also worth considering. By offering a stable platform for monitoring space debris and other potential hazards, these structures could play a critical role in protecting our satellites and infrastructure from collisions. This proactive approach to space safety could help safeguard our technological investments and ensure the continued operation of vital services. It's a reassuring thought, knowing that such innovations could help shield us from the dangers lurking in the void. Speaking of safety, the implementation of a space elevator system could pave the way for new advancements in emergency evacuation procedures. In the event of a crisis on Earth or in space, these elevators could provide a swift, reliable means of relocating people or supplies, potentially saving lives. The idea of a rapid vertical escape route is both futuristic and comforting, offering peace of mind as we venture further from our home planet. Here's another point to ponder. The cultural impact of space elevators could be just as significant as their technological contributions. By providing easier access to space, these structures could inspire new forms of art, literature, and media, exploring themes of exploration, unity, and human potential. Imagine a renaissance of creativity, fueled by the limitless possibilities of space travel and the beauty of our planet viewed from above. This artistic exploration could bring people together, transcending borders and cultures to celebrate our shared dreams. And let's not forget about education. By incorporating space elevators into curricula around the world, educators could ignite students' imaginations and inspire the next generation of scientists, engineers, and explorers. This focus on space exploration and innovation could encourage young minds to pursue careers in science, technology, engineering, and mathematics, driving progress and discovery for generations to come. Can you picture a classroom of eager students, their eyes wide with wonder as they learn about the future that awaits them in the stars? The interdisciplinary collaboration required to bring space elevators to fruition could also lead to breakthroughs in other scientific fields. As experts from different disciplines work together to solve complex challenges, they may uncover new knowledge or technologies with applications beyond space exploration. This cross-pollination of ideas could lead to advancements in medicine, materials science, and environmental sustainability, benefiting humanity in countless ways. It's remarkable to think how one ambitious project could serve as a catalyst for progress across so many domains. Finally, consider the philosophical implications of space elevators. By expanding humanity's reach into the cosmos, these structures could prompt us to re-evaluate our place in the universe and our responsibilities to one another and our planet. As we look back at Earth from the heavens, we might gain a renewed appreciation for its beauty and fragility, inspiring us to protect and cherish our home. This broader perspective could foster a sense of interconnectedness, reminding us that we are all part of a shared journey through the vastness of space. As your mind drifts through these captivating possibilities, let the gentle flow of ideas lull you into a peaceful state of wonder. Imagine a future where the boundaries between Earth and space blur, where the sky becomes a bridge to new horizons and opportunities. With each breath, let go of the weight of the day and allow your dreams to soar among the stars, guided by the promise of discoveries yet to come. Let me share something intriguing about the practicality of space elevators. They could dramatically reduce the environmental impact associated with traditional rocket launches. Whereas rockets burn vast amounts of fuel, releasing emissions into the atmosphere, a space elevator would operate more like an electric train, quietly transporting payloads with minimal ecological footprint. Can you imagine the profound difference this could make in our efforts to combat climate change? By lessening our reliance on rockets, we could significantly decrease the pollution generated by our journeys into space, making our exploration efforts more sustainable for the planet. Speaking of sustainability, here's an interesting thought. The materials used to construct space elevators could lead to breakthroughs in manufacturing and construction here on Earth. The search for lightweight, ultra-strong materials like carbon nanotubes or graphene could revolutionize industries, leading to more efficient vehicles, buildings, and even electronics. Isn't it amazing to think that the quest to build a tether stretching tens of thousands of kilometers into the sky could transform everything from the clothes we wear to the bridges we cross? Now, did you know that space elevators could play a role in space tourism? Picture this: a serene days-long ascent up a space elevator with panoramic views of Earth growing smaller beneath you. As travelers drift upwards, they'd experience the gradual transition from gravity-bound to weightlessness, offering a gentle introduction to the wonders of space. This leisurely journey could make space travel accessible to more people, providing a comfortable alternative to the intense forces experienced during rocket launches. It's a captivating vision, isn't it? This reminds me of another fascinating possibility. Space elevators could become vital transportation links between Earth and future lunar or Martian colonies. By extending tethers to these celestial bodies, we could facilitate the transfer of people and resources, supporting the growth of off-world communities. Imagine a network of elevators connecting planets and moons, creating a cosmic web of exploration and collaboration. The sheer scope of such an endeavor is truly mind-boggling, yet undeniably thrilling. Here's something you might find surprising. The concept of a space elevator has been around for over a century. It was first proposed by a Russian scientist named Konstantin Tsiolkovsky in the late 19th century, inspired by the sight of the Eiffel Tower reaching into the sky. This idea, born from one man's imagination, has since captured the minds of engineers and dreamers alike, proving that even the wildest visions can inspire real-world innovations. Have you ever wondered how many of today's technologies started as nothing more than a dream? Speaking of dreams, the development of space elevators and skyhooks could lead to the creation of new industries in orbit. From manufacturing products in microgravity to harvesting resources from asteroids, the economic potential of space-based enterprises is vast. These structures could serve as gateways to new frontiers, opening up business opportunities that were once the stuff of science fiction. It's fascinating to consider how economies might shift as space becomes more accessible, with industries flourishing in the space between worlds. And here's something intriguing. Space elevators could also enable us to harness solar power more efficiently. By placing solar panels along the tether, we could capture energy directly from the sun, converting it into electricity for use on Earth. This clean energy solution could help mitigate our reliance on fossil fuels, providing a sustainable way to meet the world's growing energy demands. Isn't it remarkable to think that a simple vertical structure could serve as a bridge to a greener future? Here's another angle to ponder. Space elevators and skyhooks could enhance our ability to conduct long-term scientific experiments in orbit. Without the constraints of launch windows or limited payload capacities, researchers could deploy instruments and equipment more easily, conducting studies that require sustained observation of Earth's climate, atmospheric conditions, or cosmic phenomena. The potential for scientific breakthroughs is immense, promising to deepen our understanding of both our planet and the universe beyond. Speaking of cosmic phenomena, did you know that a space elevator could help us study the effects of gravity on biological organisms? By positioning research modules at different points along the tether, scientists could investigate how varying levels of gravity impact plant and animal life. This research could yield valuable insights into human health during prolonged space travel, paving the way for future missions to distant planets. It's exciting to think that space elevators could unlock secrets that enhance our ability to thrive in space. Now, consider this. Space elevators might also influence our cultural perceptions of space. By making space travel more commonplace, these structures could demystify the cosmos, fostering a greater sense of connection between Earth and the stars. As people journey upwards, they might experience a profound shift in perspective, gaining a new appreciation for the vastness of the universe and the fragility of our planet. Such experiences could inspire a renewed commitment to preserving our home and exploring the wonders of space. Speaking of preservation, the construction of space elevators could lead to advancements in disaster management. By developing technologies to withstand the unique challenges of space, we might also create more resilient infrastructure on Earth. From earthquake-proof buildings to flood-resistant designs, the knowledge gained from building a tether to the sky could help us better protect our communities from natural disasters. It's fascinating to see how the pursuit of one dream can yield unexpected benefits for all of humanity. And here's a thought to leave you with. As we reach towards the stars, space elevators could symbolize humanity's inherent desire to explore and connect with the universe. These ambitious structures remind us that, despite the challenges we face, our curiosity and ingenuity know no bounds. They stand as a testament to our collective potential, urging us to look beyond the horizon and imagine what lies beyond. As you drift into a restful slumber, let your dreams soar among the possibilities that await, inspired by the promise of a future where the sky is no longer the limit, but merely a beginning. Let me share something interesting with you: the concept of a skyhook, which is a related but distinct idea from space elevators. Imagine a giant rotating tether in space that could pick up payloads from Earth's surface and fling them into higher orbits or even to other planets. This clever mechanism could drastically reduce the energy and fuel needed for space travel, making it more efficient and sustainable. Can you picture the elegance of such a system gracefully spinning in the vastness of space? Here's a fascinating fact about the materials needed for these incredible structures. The tethers for both space elevators and skyhooks would require materials with extraordinary tensile strength and lightness. Scientists are exploring carbon nanotubes and other advanced composites, dreaming of fibers that can support their own weight over tens of thousands of kilometers. It's thrilling to think that breakthroughs in material science could one day bring these visions to life. Speaking of materials, did you know that the diameter of a space elevator's tether could be as thin as a pencil lead while still being incredibly strong? This slender thread, stretching from Earth's surface to geostationary orbit, would be an engineering marvel, balancing immense forces with delicate precision. Imagine the awe of standing beneath it, looking up at a nearly invisible line connecting Earth to the stars. Here's something you might not have considered. Space elevators could provide a unique vantage point for monitoring Earth's ecosystems. From the higher reaches of the tether, sensors and cameras could capture detailed images and data, offering new insights into climate patterns, deforestation, and ocean health. This perspective, high above our planet, could become a powerful tool for conservationists and scientists working to protect our environment. And here's another angle to ponder. The construction of a space elevator might spark a new era of international collaboration. Such a monumental project would likely require the combined expertise and resources of many nations, fostering cooperation in pursuit of a common goal. This spirit of unity could extend beyond the engineering feat itself, influencing global efforts to address other challenges, from space exploration to climate change. Have you ever wondered about the potential for tourism with these structures? Space elevators and skyhooks could open the door to an entirely new kind of travel experience. Tourists might embark on journeys that offer panoramic views of Earth and space, creating memories that last a lifetime. Imagine sipping a cup of tea while watching the sun rise over the curvature of our planet, a gentle reminder of the beauty that surrounds us. Here's something surprising. Space elevators could transform the way we approach satellite deployment. By providing a stable platform from which to launch satellites, these structures could reduce costs and increase precision, making it easier to maintain and expand our networks in orbit. This could lead to more reliable communication systems, weather forecasting, and global positioning services, enhancing our daily lives in countless ways. Speaking of satellites, did you know that space elevators could help reduce space debris by offering a more controlled method of launching and retrieving objects? These structures might minimize the risk of collisions and contribute to the long-term sustainability of our orbital environment. It's a small step toward preserving the space around our planet, ensuring it remains accessible for future generations. Here's an intriguing thought. If space elevators become a reality, they could pave the way for human settlement beyond Earth. By facilitating the transport of construction materials and supplies, these structures might support the building of habitats on the Moon, Mars, or even asteroids. Imagine a future where humans live and work among the stars, expanding our presence throughout the solar system. Have you ever considered the potential educational impact of these projects? Space elevators and skyhooks could serve as inspiration for students worldwide, sparking interest in science, technology, engineering, and mathematics. By witnessing the construction and operation of such awe-inspiring structures, young minds might be encouraged to pursue careers in fields that push the boundaries of human knowledge and capability. And here's a fascinating possibility. Space elevators could revolutionize the way we think about energy. By using the motion of the tether to generate electricity, these structures might contribute to a new era of clean, renewable energy. Imagine a world where the power of gravity itself helps to fuel our future, reducing our reliance on fossil fuels and promoting a more sustainable way of living. Speaking of energy, did you know that space elevators could help us study the effects of cosmic rays? By placing sensors at various points along the tether, scientists could gather data on these high-energy particles, improving our understanding of their impact on human health and electronic systems. This research could lead to new protective measures for astronauts and space-based technologies, enhancing the safety of our ventures beyond Earth. Finally, consider this. Space elevators might influence our cultural imagination, becoming symbols of human achievement and aspiration. As these structures become part of our reality, they could inspire art, literature, and music, reflecting our journey from earthbound beings to cosmic explorers. Imagine standing at the base of a space elevator, gazing up at the sky and feeling a profound connection to the universe, a reminder of the endless possibilities that await us among the stars. As you drift deeper into relaxation, let your imagination wander through these fascinating possibilities, carried on the gentle currents of curiosity and wonder. Let me share something intriguing with you. Space elevators could drastically change the economics of accessing space. Currently, a significant portion of the cost of launching anything into space is tied to fuel and rocket technology. A space elevator could slash these costs by providing a reusable, energy-efficient way to transport goods and people beyond our atmosphere. Imagine the possibilities for businesses and researchers with this new affordability, opening up space to more participants than ever before. Here's another thought. The concept of a space elevator is not as new as you might think. The idea was first proposed by Konstantin Tsiolkovsky, a Russian scientist over a century ago in 1903. He was inspired by the Eiffel Tower and envisioned a structure reaching from the Earth's surface into the heavens. Can you imagine having such an innovative vision during a time when even flight was in its infancy? Speaking of historical connections, did you know that the idea of a skyhook was explored in science fiction long before it was considered a viable engineering project? Authors like Arthur C. Clarke and John D. MacDonald featured these concepts in their stories, capturing the imagination of readers worldwide. Fiction often paves the way for reality, doesn't it? Here's something to ponder. While Earth is the primary focus for space elevator construction, scientists are considering the Moon and Mars as potential sites as well. These celestial bodies have lower gravity, which means the materials required might not need to be as strong, making construction potentially more feasible. Imagine the Moon becoming a hub for space travel and exploration, linked to Earth by a slender ribbon of technology. Consider this. The climbers that ascend the space elevator would need to be powered in unique ways. Some proposals suggest the use of lasers on the ground to provide energy wirelessly, allowing the climbers to ascend efficiently without carrying heavy fuel loads. This innovative approach could enable smooth, continuous journeys up and down the tether. Here's an unexpected angle. Space elevators could enable a type of space farming. With the ability to transport materials and supplies easily, habitats in orbit or on other celestial bodies could support agricultural endeavors, This could help sustain long-duration missions and perhaps even provide new food sources for Earth. Can you imagine fresh produce grown under the stars? Let me tell you something fascinating. The concept of a space elevator might also lead to advances in robotics and automation. These systems will likely need sophisticated robots for maintenance and construction, pushing the development of AI and machine learning technologies. The skills and tools developed could have far-reaching applications benefiting industries back on Earth as well. It's interesting to note that space elevators could play a crucial role in planetary defense strategies. By providing a stable platform for launching and monitoring satellites, they could enhance our ability to track potentially hazardous asteroids, improving our chances of deflecting them if necessary. This proactive approach could safeguard our planet from unexpected cosmic threats. And here's a thought-provoking fact. The physics of space elevators could offer insights into gravitational waves and other cosmic phenomena. The tether's interaction with Earth's gravity field could serve as a natural laboratory, helping scientists study these enigmatic forces in new ways. Imagine the breakthroughs that could emerge from such research, deepening our understanding of the universe. Consider the cultural implications of a space elevator. It could become a symbol of peace and prosperity, transcending borders and uniting humanity in a shared vision of progress. As people from different nations collaborate on this monumental endeavor, they may foster a greater sense of global solidarity, a much-needed sentiment in today's world. Have you ever thought about the environmental benefits? By reducing our reliance on rockets that burn vast amounts of fuel, space elevators could lessen the environmental impact of space launches. This cleaner method of reaching orbit could help preserve our planet's atmosphere while still advancing our presence in space. Here's a whimsical notion. Space elevators could potentially make zero-gravity experiences more accessible. With the ability to reach beyond Earth's gravity well, these structures might offer experiences previously reserved for astronauts. Imagine floating effortlessly, seeing our planet from a new perspective, a dream within reach, thanks to this incredible technology. And here's something to tickle your imagination. The existence of space elevators might inspire new architectural styles here on Earth. The technology and aesthetics of such a futuristic structure could influence everything from skyscraper designs to public artworks, blending the boundary between Earth's landscapes and cosmic aspirations. Finally, think about the long-term impact on human society. Space elevators could redefine our relationship with the cosmos, making space not just a frontier to explore, but a place to inhabit. As these structures become part of our infrastructure, they might fundamentally change how we perceive our place in the universe, encouraging us to look beyond our planet and dream of what lies beyond. As you drift further into relaxation, let these surprising insights weave into your thoughts, nurturing a sense of wonder and curiosity about the future that awaits us among the stars. Imagine the profound shift in our logistics networks once space elevators become mainstream. The movement of goods to and from orbit could become as routine as shipping cargo across the seas today. This efficient transport system could revolutionize industries like manufacturing, where products are assembled in the microgravity of space, allowing for new materials and processes not possible on Earth. Have you ever thought about how this could transform our economic landscape? Speaking of transformations, let's consider space elevators and skyhooks as catalysts for international cooperation. By providing critical infrastructure that benefits all of humanity, these projects could encourage countries to work together toward common goals, fostering peace and collaboration on a scale we've yet to see. Here's something to ponder. Space elevators could play a key role in space-based solar power systems. Imagine a network of solar panels in orbit, continuously collecting energy from the sun and transmitting it back to Earth. The elevator could provide the perfect means to deploy and maintain these systems, potentially offering a renewable and limitless energy source. Can you envision a world powered by such clean energy? And on the topic of energy, the construction of a space elevator itself would require a massive amount of resources and energy investment initially. But once operational, it could significantly reduce the energy costs associated with space travel, transforming how we approach energy consumption on a planetary scale. This balance between initial expenditure and long-term savings is a fascinating aspect of space elevator planning. Did you know that the tether of a space elevator would experience constant tension from gravity and centrifugal forces? This constant state of stress means that the materials must be incredibly strong and resilient. Research into these materials, such as carbon nanotubes, could lead to breakthroughs in other industries, providing us with stronger, lighter materials for use on Earth. Another fascinating fact is that space elevators could enable more detailed and consistent scientific observations from space. With a stable platform, we could have instruments constantly monitoring the Earth and surrounding space, offering new insights into our planet's climate, weather patterns, and even the health of our atmosphere. This could be vital for understanding and combating climate change. Imagine the potential for education and inspiration. Space elevators could host educational platforms, allowing students and educators to experience space in a more interactive and engaging way. This could inspire a new generation of scientists, engineers, and explorers, all fueled by first-hand experiences and a deeper understanding of our universe. On a more whimsical note, consider the possibility of arts and culture being elevated to new heights. Artists could create installations or performances at different points along the elevator, using the view of Earth and the vastness of space as their backdrop. This blending of art and technology could give rise to new forms of expression, capturing the imagination of people worldwide. And speaking of imagination, think about the potential for space elevators to act as a financial bridge to the stars. By lowering the cost of accessing space, they could enable burgeoning space tourism industries and make commercial ventures in space more viable. We could see a future where space is not just for governments and large corporations, but accessible to smaller businesses and even individuals. Consider the health implications as well. Space elevators might provide new opportunities for medical research and treatment options. The microgravity environment could be used for unique studies on diseases, the effects of gravity on the human body, and even the development of new pharmaceuticals. Can you imagine the breakthroughs in medicine that could come from such research? Here's something futuristic to think about. As space elevators become part of our landscape, they might lead to advancements in safety and security technologies. The need to protect such a vital piece of infrastructure could drive innovations in surveillance, monitoring, and defense systems, which could have applications both on and off Earth. In terms of sustainability, the notion of a space elevator aligns with a growing focus on preserving our planet. By offering a cleaner, more efficient way to reach orbit, these systems could support a range of environmentally friendly technologies. This includes everything from reducing carbon emissions from rocket launches to supporting green projects in space and on Earth. Space elevators could also become a tool for enhancing global connectivity. With easier access to space, satellite networks could expand, improving communication systems worldwide. This could lead to better internet access, especially in remote areas, bridging the digital divide and fostering global communication. As you let these ideas settle into your thoughts, think of how space elevators and skyhooks represent not just technological achievements, but also symbols of humanity's potential to innovate and cooperate. They remind us of the wonders that lie beyond our reach and the incredible things we can achieve when we reach for the stars together. Allow these reflections to drift like stardust through your mind, guiding you toward peaceful dreams of the cosmos and all its possibilities. Let me take you on a journey into the intriguing intricacies of space elevators and skyhooks that might just surprise you. Did you know that the concept of space elevators dates back to the late 19th century, when Russian scientist Konstantin Tsiolkovsky first imagined a tower reaching beyond the Earth's atmosphere after seeing the Eiffel Tower in Paris? His vision laid the groundwork for what would become a futuristic concept, sparking imaginations and scientific endeavors for over a century. Here's a fascinating thought. The potential for space elevators to significantly reduce the time required to reach geostationary orbit. Traditional rockets take hours to get payloads to such altitudes, but a space elevator could do so in a matter of days, offering a smoother, more gradual journey. This change in travel time could open up new possibilities for satellite deployment and maintenance, making space more accessible than ever before. Speaking of accessibility, consider how space elevators could revolutionize the way we approach space tourism. Instead of a high-speed rocket launch with its associated risks and costs, tourists could experience a gentler ascent into space, akin to a long yet breathtaking elevator ride. Imagine watching the curvature of the Earth unfold beneath your feet, a serene journey that might democratize access to the stars. And here's something else. The concept of skyhooks, often paired with space elevators in discussions about advanced space transport. Unlike an elevator, a skyhook involves a rotating or stationary tether that can pick up payloads from Earth's atmosphere and fling them into space with minimal energy consumption. This clever use of physics could drastically cut the costs and energy required for launching objects into orbit. On the topic of cost reduction, it's worth noting that the construction of a space elevator could, over time, pay for itself through savings on launch costs. With current rocket technology, getting payloads to space is expensive and resource-intensive, but a functioning elevator or skyhook could reduce these expenses by a factor of 10 or more, making the vast reaches of space more financially viable. Here's a surprising thought about the environmental impact. Space elevators could reduce the environmental footprint of space exploration. Traditional rocket launches release tons of carbon dioxide and other pollutants into the atmosphere, but by relying on electricity, a space elevator would largely eliminate these emissions, aligning with global efforts to combat climate change. Did you know that the idea of using a space elevator isn't just limited to Earth? There's potential for constructing similar systems on the Moon or Mars, where the lower gravity makes such projects more feasible. These extraterrestrial elevators could facilitate the transport of materials and people between the surface and orbit, aiding in the establishment of permanent colonies. Now, think about the challenge of constructing a tether strong enough for an Earth-based space elevator. The material would need to be incredibly strong and light, characteristics offered by carbon nanotubes and other advanced materials still in development. This research into super-strong materials could have ripple effects across various industries, leading to breakthroughs in everything from construction to telecommunications. Here's another intriguing possibility. Space elevators and skyhooks might enhance disaster response efforts. By improving access to satellites and space-based observation platforms, these systems could provide more timely information during natural disasters, such as hurricanes and earthquakes, potentially saving lives by improving early warning systems and response coordination. On a more speculative note, consider the opportunity for space elevators to aid in harvesting resources from asteroids. With easier access to orbit, it could become feasible to capture and mine asteroids for valuable materials, such as rare metals and water, which could support life and technology both on Earth and in space. Moreover, the construction and maintenance of a space elevator could foster new kinds of jobs and industries. From engineers designing the systems to operators and maintenance crews, a vast array of new employment opportunities could arise, stimulating economies and encouraging educational programs focused on space sciences and engineering. A fun fact to ponder is the potential cultural impact of having such monumental structures. They could become iconic landmarks akin to the Great Wall of China or the Pyramids of Giza, drawing visitors and serving as a testament to human ingenuity and ambition. These structures might inspire art, literature, and a renewed interest in space and science. Think for a moment about the psychological impact of space elevators and skyhooks. By making space more accessible and routine, they could fundamentally change how we view our place in the universe. This shift in perspective could lead to a greater appreciation for the fragility of our planet and a stronger desire to preserve it for future generations. On a final note, the cooperative nature of building such grand projects could lead to unprecedented levels of international collaboration. With the shared goal of reaching and utilizing space more effectively, nations might come together to pool resources, knowledge, and expertise, fostering a new era of global unity and peace. As you reflect on these possibilities, allow your mind to wander to the ends of the tether, where dreams of the cosmos are tethered not just to technology, but to our collective hopes for a future where space is within reach and the stars are no longer distant. Let these thoughts drift gently through your imagination, wrapping you in a blanket of cosmic wonder as you prepare to journey into restful sleep. As we continue our gentle exploration of the intriguing world of space elevators and skyhooks, let me share an interesting detail about the sheer scale that these structures would entail. Imagine a tether stretching from the Earth's surface all the way to geostationary orbit, approximately 36,000 kilometers above the planet. To put that in perspective, it's like having a cable extending nearly 3 times the diameter of Earth, a staggering feat of engineering. Did you know that the concept of space elevators was first popularized by a science fiction writer, Arthur C. Clarke, in his novel The Fountains of Paradise, described a space elevator linking Earth to a satellite in geostationary orbit. His imaginative narrative brought the idea to the forefront of scientific inquiry, inspiring researchers to explore its feasibility in the real world. Here's a fascinating thought. Space elevators could theoretically be powered by solar energy. By harnessing the abundant sunlight available in space, they could operate with minimal environmental impact, offering a sustainable alternative to chemical rockets. This aligns beautifully with the growing global emphasis on renewable energy sources. Speaking of energy, let's consider the innovative concept of using electromagnetic propulsion for space elevators. This method involves linear motors, similar to those used in maglev trains, to gently propel the elevator cars along the tether. Such technology could ensure a smooth and efficient ascent, reducing wear and tear on the structure. Now, think about the potential for space elevators to serve as cosmic launch platforms. Once payloads reach the top of the elevator, they could be released into space with significantly less energy than traditional methods require. This could open up entirely new possibilities for deep space exploration, making missions to distant planets or even other star systems more cost-effective. An intriguing aspect of space elevators is their potential role in facilitating space-based manufacturing. With easier access to orbit, factories could be established in space to produce materials that are difficult or impossible to make on Earth due to gravity. Imagine the creation of ultra-pure crystals or advanced materials for spacecraft right in orbit. Did you know that the physics of a rotating skyhook could actually stabilize the tether? By using the momentum from its rotation, a skyhook could maintain its position and orientation in space, providing a dynamic balance that reduces stresses on the cable. This clever application of physics could enhance the longevity and reliability of the system. Here's a surprising insight. The construction of a space elevator might start from the top down by initially deploying a satellite in geostationary orbit and then gradually lowering the tether towards Earth. Engineers could avoid many of the logistical challenges associated with building such a massive structure from the ground up. Consider the potential for space elevators to revolutionize global telecommunications. With satellites placed at optimal altitudes, they could offer unprecedented bandwidth and connectivity, transforming how we communicate across the globe. This could have far-reaching implications for everything from internet access to emergency services. On a more philosophical note, space elevators might alter our cultural narratives about space travel. No longer the realm of elite astronauts, the journey to space could become a shared human experience. This democratization of space exploration might reshape our collective identity, fostering a sense of global citizenship. Here's an intriguing environmental possibility. Space elevators could aid in cleaning up space debris. With easier access to orbit, we could deploy systems to capture and remove defunct satellites and debris, reducing the risk of collisions and ensuring safer navigation for future missions. Another exciting prospect is the use of space elevators for scientific research. With the ability to easily transport instruments to various altitudes, we could conduct experiments in diverse atmospheric conditions or study cosmic phenomena with unprecedented precision. This could lead to breakthroughs in our understanding of both the Earth and the universe. Did you know that building a space elevator on the Moon might actually be easier than on Earth? The Moon's lower gravity and absence of an atmosphere would simplify many engineering challenges, making it a prime candidate for early experiments in this technology. Such endeavors could lay the groundwork for lunar colonies and beyond. Consider the safety benefits that space elevators could offer. Without the explosive risks associated with rocket launches, travel to space could become much safer, reducing the potential for accidents and making space tourism a more viable industry. Finally, let's ponder the potential for space elevators to foster international collaboration in unprecedented ways. These projects would require expertise and resources from around the world, encouraging nations to work together towards common goals. This spirit of unity and cooperation might extend beyond the realm of space, influencing global relations and promoting peace. As we wrap our minds around these possibilities, let the idea of space elevators and skyhooks inspire a sense of wonder and curiosity about what lies beyond the horizon. With each fact and possibility, we move closer to a future where the cosmos is within our grasp, inviting us to dream of a world where the stars are no longer distant, but a part of our everyday lives. Let these thoughts cradle you into a peaceful slumber, as the gentle pull of gravity and the allure of the stars guide you into a restful night. Let's delve deeper into the fascinating world of space elevators and skyhooks, where possibilities bloom like stars in a clear night sky. Have you ever considered the immense potential of carbon nanotubes in space elevator construction? These remarkable structures, made of carbon, arranged in a cylindrical nanostructure, possess an extraordinary strength-to-weight ratio, making them an ideal candidate for the tether material. Their tensile strength could withstand the immense forces involved, offering a practical path forward in making space elevators a reality. Imagine a cable so strong and light that it stretches seamlessly from the Earth's surface into space. In thinking about the practicalities, you might wonder how space elevators could operate around the clock. Surprisingly, they could run continuously, unaffected by weather or atmospheric conditions that ground many traditional space launch methods. This constancy could revolutionize our access to space, making it as routine as catching a flight today. Reliability and predictability would become the norm, reducing costs and increasing the frequency of space missions beyond our current imagination. Here's a whimsical thought. Imagine using a space elevator to transport people to luxury hotels in space. With a tether reaching into orbit, space tourism could evolve into a more accessible and luxurious experience, where guests could enjoy unparalleled views of Earth from the comfort of a space-bound suite. This vision of hospitality in the heavens could redefine vacationing, offering a unique perspective on our planet and the universe. Speaking of luxurious experiences, consider the potential for space elevators to provide an unparalleled platform for astronomical observation. Situated far above the atmospheric distortions of Earth, instruments mounted on the elevator's upper reaches could achieve unprecedented clarity and precision in their observations. This could lead to groundbreaking discoveries about the cosmos, unveiling secrets of distant galaxies and the origins of our universe. An interesting aspect of space elevators is their potential to inspire educational opportunities. Schools and universities could partner with space elevator projects to offer students hands-on experience with cutting-edge technology and engineering challenges. Imagine a generation of students who, instead of reading about space, actively participate in its exploration and development. This hands-on learning could ignite a passion for science and technology, fostering a new wave of innovation and discovery. Did you ever ponder how space elevators might influence art and culture? Artists could draw inspiration from the monumental scale and futuristic aesthetics of such structures, leading to new genres of art that celebrate humanity's reach for the stars. This fusion of technology and creativity might not only produce stunning visuals, but also provoke deeper reflections on our place in the universe. Another intriguing aspect is the potential economic impact of space elevators. By reducing the costs of reaching orbit, they could open space to a wider range of commercial activities. Industries could develop entirely new lines of business, from zero-gravity manufacturing to off-world mining, each with the potential to generate substantial economic growth and job creation. And here's a thought that dances on the edges of the surreal. What if space elevators could allow us to harvest energy from outer space? With solar panels positioned in orbit, they could capture sunlight unobstructed by Earth's atmosphere, providing a continuous source of renewable energy. This energy could be beamed back to Earth, supplementing our energy needs and contributing to global energy solutions. Reflecting on societal impacts, consider how space elevators might transform global transportation networks. With the capability to move payloads to orbit, goods could be shipped globally in a fraction of the time it currently takes, revolutionizing supply chains and logistics. This increased efficiency could lead to a more interconnected and responsive world economy, where distance becomes less of a barrier to trade and collaboration. In pondering these possibilities, we must also consider the environmental benefits. With less reliance on chemical rockets, the carbon footprint of space travel could be drastically reduced, aligning with our global efforts to combat climate change. This cleaner approach to space exploration might serve as a model for other industries, highlighting the potential of technology to address environmental challenges. Let's not overlook the potential for space elevators to facilitate international scientific cooperation. With a permanent presence in space, researchers from around the globe could collaborate in new and exciting ways, sharing resources and data in real time. This global scientific community could drive innovation and discovery, pushing the boundaries of what we know and understand about our universe. Here's a curious thought. Space elevators might change how we think about distance and time. With the ability to travel effortlessly to orbit and beyond, our perception of space could shift, making the vastness of the cosmos seem more like our own backyard. This new perspective might inspire a generation of explorers and dreamers, eager to venture beyond the known and into the great unknown. As you let your mind wander through these imaginative possibilities, consider how space elevators and skyhooks could redefine humanity's relationship with space. Each innovation and discovery brings us closer to a future where the stars are not a distant dream but a reachable reality. Let these dreams guide you into a peaceful sleep, where the promise of tomorrow's adventures lull you into restful slumber. Have you ever wondered about the materials that could be used to construct a space elevator? One surprising contender is diamond nanothreads. These are essentially one-dimensional carbon structures that combine the extraordinary strength of diamonds with the flexibility of nanotubes. Imagine a cable as thin as a human hair, but stronger than steel, stretching from the Earth into space. It's a fascinating leap in material science that could bring us closer to realizing these colossal structures. Here's an intriguing thought. Space elevators could potentially make space habitats more feasible and sustainable. By providing a cost-effective way to transport materials to space, these elevators could support the construction of large-scale habitats in orbit or even on other celestial bodies. This could pave the way for permanent human settlements beyond Earth, a significant step in humanity's expansion into the cosmos. Speaking of expansion, did you know that space elevators could help us explore other planets more efficiently? Once constructed, they could serve as a base for launching interplanetary missions. The reduced cost and increased frequency of launches could accelerate our exploration of the solar system, bringing us closer to the dream of sending humans to Mars and beyond. An interesting economic angle to consider is the potential for space elevators to drive the development of new markets and industries. As access to space becomes more routine, we might see the emergence of space-based services like satellite repair and recycling. This could not only create new jobs, but also promote a more sustainable approach to managing our orbital assets. Have you ever imagined the potential for space elevators to serve as giant communication towers? Positioned high above the Earth, they could host communication satellites, providing enhanced connectivity and coverage across the globe. This could revolutionize global telecommunications, bridging the digital divide and bringing the internet to even the most remote corners of the planet. Let me tell you about the role space elevators could play in advancing scientific research. Beyond just reaching orbit, they could support the deployment of large-scale scientific instruments and observatories. This could lead to new insights into everything from climate change to the mysteries of black holes, offering a richer understanding of our universe. Speaking of mysteries, have you wondered how space elevators could impact our understanding of gravity? By extending far into space, they would create a unique environment for studying gravitational forces. Researchers could conduct experiments that would be impossible on Earth, potentially unraveling new aspects of this fundamental force. Think about the potential cultural impacts of space elevators. By making space more accessible, they could inspire a new era of space-themed art, literature, and cinema. The stories and creations that emerge from this inspiration could reshape our cultural landscape, offering fresh perspectives on space exploration and our place in the universe. An unusual but exciting concept is the idea of using space elevators to facilitate asteroid mining. By providing a stable platform for launching mining missions, they could enable the extraction of valuable resources from asteroids and other celestial bodies. This could open up new sources of raw materials, reducing our reliance on Earth's finite resources and further driving economic growth. Let's not forget the potential for space elevators to support disaster relief efforts. By offering a rapid and reliable means of transporting supplies to affected areas, they could enhance our ability to respond to natural disasters and humanitarian crises. This capability could save lives and reduce suffering, demonstrating the humanitarian benefits of space technology. Would you have guessed that space elevators could also contribute to space debris management? By providing a means to retrieve and deorbit defunct satellites and other debris, they could help clean up Earth's orbital environment. This would reduce the risk of collisions and ensure the long-term sustainability of space activities. Here's a thought-provoking idea. What if space elevators could serve as platforms for international diplomacy? By involving multiple countries in their construction and operation, they could foster collaboration and cooperation on a global scale. This shared endeavor could promote peace and understanding, highlighting the unifying power of shared challenges and ambitions. Finally, consider the potential for space elevators to influence our energy strategies. By facilitating the construction of space-based solar power stations, they could help us harness the limitless energy of the sun. This could provide a clean, renewable energy source for Earth, contributing to global efforts to combat climate change and secure a sustainable energy future. With each new possibility, space elevators and skyhooks continue to captivate the imagination. They represent not just a technological challenge, but a gateway to a new era of exploration and discovery. As you drift into a restful sleep, let your dreams carry you to the edges of the universe, where the wonders of space await. Consider the notion that space elevators could fundamentally change how we perceive time and space travel. By shortening the time it takes to reach orbit, they could alter our sense of distance in the universe, making space seem not so far after all. This change in perception might inspire more people to think of space not as the final frontier, but as an extension of our world. Have you ever pondered the environmental implications of space elevators? Unlike traditional rockets that emit greenhouse gases, elevators could provide a greener alternative for transporting cargo into space. This could significantly reduce the carbon footprint of our space endeavors, making exploration more environmentally friendly. Something particularly surprising is the potential for space elevators to act as massive scientific laboratories. Imagine a structure where experiments could be conducted at different altitudes, offering a range of atmospheric conditions. This vertical lab could yield new insights into weather patterns, atmospheric chemistry, and even the behavior of biological organisms in varying gravitational forces. Speaking of behavior, did you know that the psychological effects of traveling via a space elevator could be quite profound? Unlike the intense and brief experience of a rocket launch, an elevator ride would be much slower and steadier, perhaps akin to a long journey in a glass-walled elevator with breathtaking views of Earth. This might provide a more contemplative experience, allowing travelers to fully appreciate the transition from our blue planet to the vastness of space. And here's something to ponder. Space elevators could influence urban planning and architecture on Earth. The base station of an elevator would likely require a significant support infrastructure, potentially leading to the development of new cities or the expansion of existing ones. These spaceport cities might become bustling hubs of innovation and commerce, much like coastal cities in the age of exploration. Imagine the role of space elevators in educational outreach. By making space more accessible, they could serve as powerful tools for inspiring the next generation of scientists, engineers, and explorers. Virtual field trips and live-streamed journeys into space could become a part of school curriculums worldwide, igniting imaginations and encouraging interest in STEM fields. It's fascinating to consider the artistic possibilities that space elevators might offer. Artists could be inspired to create works that capture the essence of this incredible technology, from paintings and sculptures to virtual reality experiences. These creations could enrich our cultural heritage and offer new ways to engage with the concept of space exploration. Have you ever thought about the security implications of space elevators? As strategic assets, they would need to be protected from potential threats, both physical and digital. This could drive advancements in cybersecurity and defense technologies, ensuring the safety of this critical infrastructure. One unexpected aspect of space elevators is their potential to foster international cooperation. By involving multiple countries in their development and operation, elevators could become symbols of global unity, much like the International Space Station. This collaborative spirit could extend to other areas of space exploration, promoting peace and understanding among nations. Let's delve into the economic implications of space elevators. By dramatically reducing the cost of reaching orbit, they could lower the barriers for entry into the space industry. This could lead to a proliferation of startups and small businesses, driving innovation and competition in the space sector. Speaking of innovation, consider the technological advancements that space elevators could spur. The challenges of constructing and operating such a complex system could lead to breakthroughs in fields like robotics, materials science. These advancements could have far-reaching impacts, benefiting industries beyond space exploration. It's intriguing to think about the potential for space elevators to transform tourism. Imagine taking a leisurely ride to space, where you could enjoy stunning views of Earth while sipping a cup of coffee. Such experiences could make space tourism more accessible to the public, perhaps even as commonplace as a cruise or a flight. Have you ever imagined the potential spiritual impact of space elevators? For some, the opportunity to witness the Earth from space might evoke a profound sense of wonder and connection to the universe. This could inspire new philosophical and spiritual perspectives, enriching our understanding of the world and our place in it. Let's not overlook the potential for space elevators to support humanitarian efforts. In times of need, they could quickly transport aid supplies and personnel to remote or disaster-stricken areas, demonstrating the humanitarian benefits of space technology. Finally, consider the possibility of space elevators serving as platforms for interstellar exploration. By reducing the cost and logistical challenges of launching missions, they could enable humanity to venture beyond our solar system, pursuing the age-old dream of discovering new worlds. With each new fact, space elevators and skyhooks continue to amaze and inspire us. As you settle into a peaceful sleep, let your imagination wander to the possibilities these marvels of engineering could bring. Tomorrow, who knows what wonders await us in the ever-expanding tapestry of the cosmos? Let me share something particularly intriguing about space elevators. The sheer length of these structures is almost beyond comprehension. Did you know that a space elevator cable would need to stretch over 36,000 kilometers from Earth's surface to geostationary orbit? That's nearly 3 times the diameter of our planet. Imagine the engineering feat required to construct such a marvel. This immense length presents unique challenges, not just in terms of construction, but also in material science. The cable would need to withstand immense tension and environmental factors like radiation and micrometeoroid impacts. Speaking of materials, carbon nanotubes have been considered as a potential solution. These tiny cylindrical structures are remarkably strong and lightweight, making them ideal candidates for the space elevator cable. However, producing carbon nanotubes in the lengths required remains a significant hurdle, illustrating just how cutting-edge this technology truly is. Here's a fascinating fact about Skyhooks. They could potentially revolutionize satellite deployment. Unlike traditional methods that rely on rockets, a skyhook could gently grab and release satellites into their designated orbits, reducing the risk of damage from launch stresses. This could prolong the lifespan of satellites and lead to more sustainable space operations. Moreover, the energy requirements for a skyhook system are surprisingly efficient. By utilizing the Earth's rotational energy, a skyhook could maintain its orbital velocity with minimal additional energy input, making it an environmentally friendly option for space transport. Imagine the potential for space elevators in mining operations. In the future, elevators could facilitate the extraction of valuable resources from asteroids or the Moon. This would not only provide essential materials for space exploration, but could also supply Earth with rare minerals needed for advanced technologies. Speaking of resources, did you know that the space elevator's mobile base station, often envisioned as a floating platform in the ocean, would need to navigate constantly to avoid potential collisions with satellites and space debris? This dynamic repositioning would be guided by advanced tracking systems and precise orbital calculations. Now, let's consider the impact of space elevators on energy production. By positioning solar panels along the length of the elevator cable, we could harness solar energy more efficiently. These panels could collect sunlight without the interference of Earth's atmosphere, providing a consistent and powerful energy source that could be transmitted back to Earth. This could significantly contribute to our renewable energy solutions, helping to reduce reliance on fossil fuels. Have you ever thought about the role of space elevators in advancing telecommunications? With a permanent structure reaching into space, communication signals could be transmitted more directly and efficiently, potentially improving global connectivity. This could be a game changer for remote areas where traditional infrastructure is challenging to maintain. Speaking of connectivity, consider how space elevators might impact global travel. By providing a direct route to orbit, they could significantly reduce travel times for those venturing beyond Earth. This could make space travel as routine as transcontinental flights, perhaps even leading to the development of spaceports akin to airports. Imagine a future where traveling to a space colony is just a matter of boarding an elevator and ascending calmly into the stars. Here's a surprising thought. Space elevators could contribute to climate research. By providing a stable platform at various altitudes, they could support instruments for long-term atmospheric monitoring. This continuous data collection could enhance our understanding of climate change and weather patterns, aiding in the development of more accurate predictive models. Consider the impact on space colonization. By reducing the cost and complexity of sending materials into space, elevators could facilitate the construction of habitats on the Moon or Mars. This would support long-term human presence beyond Earth, opening new possibilities for exploration and settlement. Can you imagine the thrill of living in a community that orbits our planet? And finally, let's ponder the cultural implications of space elevators. Just as historic monuments and architectural marvels inspire awe and wonder, so too could these towering structures. They might become icons of human achievement, symbolizing our aspirations to reach beyond our terrestrial bounds. As we drift into dreams of the future, space elevators and skyhooks remind us of the limitless potential that awaits humanity among the stars. One surprising aspect of space elevators is their potential to alter our transportation network right here on Earth. Imagine a world where freight is transported directly to orbit, bypassing traditional shipping routes. This could relieve congestion on our roads and reduce the environmental impact of long-haul trucking. Such a shift could dramatically decrease carbon emissions, making our planet a cleaner place to live. Did you know that space elevators could also play a crucial role in disaster response? In the aftermath of natural catastrophes, rapid deployment of aid and personnel is vital. Space elevators, with their ability to transport goods quickly and directly to needed locations, could serve as a lifeline, bringing essential supplies to affected areas with unprecedented speed and efficiency. This utility highlights the potential humanitarian benefits of these remarkable structures. Another intriguing possibility is the use of space elevators for scientific research. By providing a stable platform at varying altitudes, elevators could support a host of scientific instruments, enabling continuous observation of phenomena such as atmospheric conditions or cosmic events. This could lead to new discoveries and a deeper understanding of our universe, as well as our own planet. Speaking of cosmic events, consider the role of skyhooks in space tourism. With their ability to gently transfer passengers to and from orbit, skyhooks could make space vacations more accessible. Imagine experiencing the awe of looking back at Earth from space, witnessing the curvature of our planet and the expanse of stars beyond. Such experiences could foster a deeper appreciation for our place in the cosmos and inspire future generations to pursue careers in science and exploration. Have you ever thought about the environmental benefits of space elevators? Unlike traditional space travel, which relies on rocket launchers that release large amounts of greenhouse gases, space elevators could offer a much cleaner alternative. This would not only reduce the environmental impact of reaching orbit, but could also set a new standard for sustainable space exploration. Here's an unexpected fact. Space elevators might change the way we approach construction on Earth. The development of materials and techniques necessary for building these structures could lead to innovations in building practices back home. We might see new kinds of skyscrapers or bridges that incorporate the strengths of space elevator technology, further blurring the line between earthly and extraterrestrial engineering feats. Imagine the potential for space elevators in education. By making access to space more routine and affordable, they could provide unique opportunities for students to engage in space-based experiments and projects. This hands-on learning experience could ignite a passion for science and technology, encouraging the next generation of explorers and innovators. Speaking of education, consider how space elevators could serve as platforms for international collaboration. The construction and operation of a space elevator would require expertise and resources from around the globe, fostering cooperation among nations. This could lead to a new era of peaceful space exploration, where countries work together towards common goals and share the benefits of their achievements. An interesting consideration is the economic impact of space elevators. By reducing the cost of accessing orbit, they could lower the barrier for entry into the space industry. This could spur innovation and competition, leading to new businesses and technologies that drive economic growth. The space economy might become a major contributor to global prosperity, just as the internet has transformed our world in recent decades. Now, let's think about how space elevators could influence our cultural perspective. As they become a part of our daily lives, they might shift our view of Earth from a collection of separate nations to a single interconnected planet. This broader perspective could encourage a sense of global citizenship and responsibility, reminding us of the importance of preserving our home for future generations. Here's another fascinating thought. Space elevators could aid in planetary defense. By providing a rapid response mechanism for deploying equipment and personnel, they could help mitigate the threat of potentially hazardous asteroids. This proactive approach to planetary protection could safeguard our planet from future impacts, ensuring the continued survival and prosperity of life on Earth. Have you considered the potential for space elevators in art and storytelling? As a new frontier in human achievement, they could inspire a wealth of creative expression. Artists and writers might explore themes of exploration, unity, and the human spirit, using space elevators as a symbol of our aspirations and achievements. Finally, imagine the symbolic significance of space elevators and skyhooks. Like the pyramids of ancient Egypt or the cathedrals of Europe, these structures could become enduring symbols of human ingenuity and determination. They might inspire future generations to dream big and pursue the seemingly impossible, reminding us of our capacity to reach for the stars and beyond. As we drift off to sleep, let's ponder the limitless possibilities that space elevators and skyhooks hold for humanity's future. These marvels of engineering serve as a testament to our inventive spirit, and as we journey through the realms of imagination, we are reminded of the incredible potential that lies ahead. May our dreams be filled with visions of the cosmos, where each new idea brings us closer to realizing our shared destiny among the stars.